our channel ClassFly community. So today we will be doing the RC series circuit. So see, from the topic we can understand that R means our resistance, C is our capacitance, and we will give both this resistance and the capacitance in a form of the series. Series means R will be also in the same line as well as the capacitor will be also in the same line. So we have drawn the circuit already. So this is a applied voltage, this is V, or you can also give this symbol, that is a AC symbol. So this will be an applied voltage, and this is a resistance, and this is a capacitor. So voltage in the resistance will be denoted as VR, voltage in the capacitance will be VC, and there will be a I flowing between both resistance and a capacitance. So in your exam you need to define the terms that you are using in the circuit. Okay, so see, V is the applied voltage, I is the RMS value of the current. RMS means root mean square. VR is the voltage across resistance, that means the voltage which is in the resistance. So we can write VR equal to IR because we know voltage is equal to current into resistance. Similarly VC, that means this is the voltage across capacitance, that is I dot XC. XC means a kappa. Yes, you are right. It is capacitive reactance. Capacitive reactance. Now see, we have whatever we have to do, what we have to do in this circuit. We have to find impedance. Also we have to find the phase angle, the current, the power factor, I am writing in short PF, the three powers, active power, reactive power, and apparent power. So from this simple circuit we have to find all these 7 points. So one by one we will do. So whenever we need to do the impedance, we need to draw our phasor diagram. So how we will draw the phasor diagram? Forget about this diagram. See, what is the common thing between this resistance and the capacitance? I. So this I will be in this line, right? Similarly I have drawn here, this I is in this line because this is the common, so it is in this axis. Now you know that the voltage across resistance is in the direction of the current, so VR will also be in this direction. But whenever voltage across capacitance, it is said that the current will be leading, right? Current will be leading by 90 degree. So that's why, that means VC will be lagging here by 90 degree, right? So that's why our VC, that is a voltage across the capacitance, will be lagging in this diagram from the current. Okay, now see, whenever we do VC and VR, when we summation this, we will get a voltage, right? So we will draw a straight line like this and we will represent it as V. Simple. So now see, according to the Pythagoras theorem, we know that hypotenuse square is equal to the base square plus the perpendicular square. So for the impedance finding, that is a Z, we will see the hypotenuse here in the phasor diagram? Yes, it is the V. So we will write V square equal to, and what is a base? It's the VR. So we will write VR square plus VC square because it is the perpendicular. See, now we can write that VR is equal to I into R. So we will change VR to IR and VC to IXC, that is the current and the capacitive reactance, and we will put the the square root, and in this thing, when we square each of them, we get I square R square plus I square XC square, right? We get I square as common. So we will bring I square outside like this, and we will write R square X square C. Now when we bring it outside the square root, we will get I then. So we have written I square root R square plus XC square. Now when I bring this I down, that is V by I, we know that voltage by I is our impedance. This is our impedance. So Z is equal to R square plus XC square. So we got our impedance. And one more thing, we know that XC is our 1 by omega C. So we can write this equation as Z equal to R square plus 1 by omega C square. Okay, so we have completed our first one, that is our impedance. Now we will need to do the phase angle. So for the phase angle, we have to find tan phi. So we know that tan phi is perpendicular by base. So our perpendicular is VC and our base is VR. And we know that VC is IXC, that is current into capacitive reactance, and VR is our I into R. And we see that I and I get cut and we are left over with XC by R. And we know that XC is equal to 1 by omega C. So we can write this as 1 by omega CR. So we also find a second, that is our phase angle. Now let's move on and find a current. So for finding current, we know that current is equal to voltage by resistance, and for AC we know that a resistance is an impedance. So we know voltage will be V, and we have already found a Z value. So it is square root of R square plus XC square, and we know that XC is equal to 1 by what? Yes, you are correct, 1 by omega C. So you can write V by root under R square plus 1 by omega C square. So we are completed with the current also. Now let's do our power factor. So you know that power factor means cos phi. So cos phi means base by hypotenuse. So let's again make the phasor diagram here. So we know that I is like this. I is common in both, that is for the resistance and the capacitance. And we know that in resistance, that is the voltage across resistance, it is in the same direction with the current, and the VC will be lagging by 90 degree. So VC is at this. So from here we can say that VC and VR will give us the V. So cos phi is equal to base by hypotenuse. So our base is VR and our hypotenuse is H. So we know that VR is I into R and V is I dot Z. So I get cut and we are left with R by Z. Right? So we can also write this as R by root under R square plus XC square, and this can be forward changes to 1 by omega C square. So we have also find a cos phi. Similarly, let's find the sin phi also, because it will be used in a reactive power. So let's find the sin phi also. So sin phi is perpendicular by hypotenuse. So our perpendicular is VC and our hypotenuse is V. So our VC is I dot XC and a V is I dot Z. So I gets cut and we are left with XC by Z. So we will write XC by Z. Similarly, you can write this as 1 by omega c root under r square plus xc square, and this can be again written as 1 by omega c root under r square plus 1 by omega c square. Like this you can write. Now let's move on and solve the active power. You know that active power is represented as P. So P is equal to Vi cos phi. We have already find a cos phi. It is R by Z. So we are writing R by Z. And when we bring this Z here down with the V, we know that V by Z is I. So we can write our active power as I square R, and the active power unit is what? So we are completed with the active power. Now let's see our reactive power. We know that we denote reactive power as Q, and it is Vi sin phi. I told that we are already doing the sin phi so that we can use it later. So sin phi is Xc by Z. So we will write Xc by Z and Vi. We will take the Z here down the V. So we know that Vz is I. So we will get I square Xc and the unit is var. Similarly, for the apparent power, we know that it is denoted by S, and S is equal to V dot I, and we know that V is I dot Z, right? So when we do I dot Z, we get I square Z, and its unit is VA, and we know that VA is what? Volt ampere. And var is what? VAR is what? Volt ampere reactive. Right? So we have completed all our 7 points. So let's recheck once. Impedance we have done, phase angle we have done current, we have done power factor, we have done active power, reactive power, as well as apparent power. So today's lecture ends here. I hope you all find this lecture very interesting. Till then, be happy and have a great day.
Now is the code time. People who are crazy enough to think they can change the world are the ones who do it. I hope all of you understood the lecture of today, and thank you for watching.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.